So we're going to look at distributive property, distributing expressions, and these are going to create equivalent expressions. It is kind of like the opposite of factoring. So when I'm looking at it, this is going to lead us into one of the methods to solve these, and there's actually three ways that we can look at to do it. So if I was going to create a model to show 2 times 5, we'd want to make an area model, because we know area of a rectangle is length times the width. So I'm going to just, for the sake of this, these are always going to be my length and these are always going to be my width, but they are interchangeable. So I say it has a length of 2 and a width of 5, means the area 2 times 5 would be 10. If I was going to do one with a variable, I have a length of 2 and a width of b. So my area would be 2 times b, which is 2b, and that means 2 times b. Now when I get into an expression like this one, 2 times the quantity of a plus b, then I'm going to say, okay, my length is 2 and my width is a plus b. So that means I don't know how long this side is, but I know the distance from here to here is the length of a, which we'll just say is this far, and it doesn't matter where you put the line at. So the length of a is from here to here, the length of b is from here to here. So now I have 2 smaller rectangles. I do want to find the area of the whole thing, but I'm going to do it one piece at a time. So 2 times a is 2a, and 2 times b is 2b. So the area of this whole thing, 2 times a plus b, equals 2a plus 2b, because I would have to add this plus that. That's one way you can do distributive property, is to do an area model. Another way that we've kind of talked about, this means I have, multiplication is repeated addition. So 2 times a plus b, right? That could be 2 sets of a plus b. So it would be a plus b plus a plus b. We know when we're adding these, we can only add the terms that are alike. So 1b plus 1b makes 2b. A plus a is 2a. So I have 2 sets of this. So this is a different method. We'd call that the repeated addition method. And the last way that we could do it is the traditional way, 2 times the quantity of a plus b. What I would do here is to this, when this 2 is right next to the parentheses, it means multiplication, so it's saying 2 times everything inside of here. So I have to distribute the 2 through multiplication. So 2 times a plus, I'm going to also have to multiply it by this one, 2 times b. 2 times a is 2a, 2 times b is 2b. The next example I want to look at would be double this amount. So I'll start off with the model, 2 times 3x plus 4y. So we'll start off with the model way. Again, it's 2 times everything inside of here. So I have, a length of 2 and a width of 3x plus 4y. I cannot add 3x and 4y. So I'm going to say this part's 3x, this part's 4y. 2 times 3x is 6x. 2 times 4y is 8y. So this would equal 6x plus 8y. That is the same thing. It is equivalent to 3x plus 4y. They're different ways of writing the same thing. If I wanted to do the repeated addition method, two sets of this would be 3x plus 4y plus 3x plus 4y. 4y and 4y is 8y, 3x and 3x is 6x. Notice I'm getting the same thing. The last method is your standard method. 2 times the quantity of 3x plus 4y. So I am distributing this 2 to everything. 2 times 3x plus 2 times 4y. 2 times 3x is 6x. 2 sets of 4y would make 8y. This, and this are all equivalent. And you know that we were doing factoring, so this kind of is the reverse of factoring. When we were factoring an expression, we started off with this, and then we figured out, oh, the greatest common factor is 2, so I factored out a 2, and then I made it go to here. This is just the reverse process of that factoring. One last one I want to look at. Start off with the model. This would be y times 4x plus 5. This is the only time when I cannot do the repeated addition, because I don't know how many sets I would need. You know, if there was a 4 here, I'd put 4 sets of it and add them together. But when there's a y, it's an unknown number, it's a variable, so we cannot do repeated addition when we have a variable on the outside. Y times 4x is 4xy. 5 times y is 5y. So this is 4xy plus 5y. I cannot add these together. This is as far as I can go. This would be, you know, simplifying the expression, cleaning it up, because I can't add them because this has an x and this doesn't. They have to be exactly the same in order to add them. This is saying 4 times x times y plus 5 times y. I'd have to do this multiplication before I could ever add. Traditional method. Y times 4x is 4xy plus y times 5, which is 5y. Now if this was like a subtraction sign in here, then you'd do the same thing. You just bring down the subtraction sign and it would be the same.